Welcome everyone. This is the seminar Enabling Data Mesh, How Data Modeling Builds Cross-Domain Communication with Juha Korpela of Ellie Technologies. Hi Juha.
Hello.
So it's, as I've said, a really very hot topic these days with almost 100 registrations for this event. And I would also say it's a really abstract concept if you look at it first. I mean, it's not technology, it's actually technology agnostic, solution agnostic. It's independent of those things. It's really a different way of thinking and looking at data organizations, data driven business, and data architecture. So, but every now and then a real topic comes up and stands out, and we have to look at it because it makes you think different. And I think that's the most important of the data mesh, that it really brings you back from the centralized data warehouse way of thinking or the data lake, which is something that a lot of people look at. It's really different. And we're very glad that there's now a book about it by the inventor of the concept, Zhamak Dehghani from ThoughtWorks. We have it, you have it, Juha. So that's really something. And there's even different chapters online, which you can download for free if you want to read more about the data mesh. But the whole book is interesting. Definitely the way you need to implement it is very interesting. But I also think it's about communication. There's a couple of things that are crucial for the data mesh. It's decentralized and domain driven. That's important. What is the most important, I think, is that it shifts left. It makes you step away from technology and solutions towards more the business, the concepts, the business terms, and that sort of things. And that's where actually Ellie has a powerful offering with the glossary modeling tools, the data modeling tools at the business level. And that's how we came together. The topic is very interesting, and Juha is very interesting, and his company is very interesting. So we brought those two things together. He also wrote a couple of blog posts about the data mesh, which I've discovered a year and a half ago. So that also made me decide to do something about the data mesh with Juha from Ellie Technologies. Juha, the floor is yours.
Excellent. Thank you, Patrick. And thanks for inviting me here. Indeed, this is topic. This is super interesting topic. And just want to kind of say a word that came to my mind as you were describing it there. I think Dehghani in this book describes data mesh as a socio-technical framework, which I think is great, because we're not talking about just technological implementations here. We're talking about even a sociological change in the way that we look at data management. And as you said, from the old kind of centralized data warehousing kind of way of thinking into something else, which doesn't necessarily mean it's completely different from data warehousing, but it's not centralized, which I think is the core here. But indeed, let's get started with this. And just to introduce myself to the audience here, hello, Juha Korpela is my name, hailing from Helsinki, Finland, and working at Ellie Technologies as the Chief Product Officer. Of course, product development, the roadmap, where we are going with the product is my basic day job, but I also do all kinds of methodological and training things and so on. Bit over a decade now, data management stuff, data modeling, lots of all kinds of agile development, which is one of the reasons this whole mesh thing kind of feels interesting to me. You can see my details there. Feel free to hit me up if there's any questions. But the reason we're here is basically that we really, at Ellie, we really believe in this kind of domain-driven and kind of business-driven thinking. And why it is so good match with this data mesh is that because the data mesh is purely kind of domain focused, domain oriented. What is the actual content of your business that you're interested in? That is what the mesh is made of. Well, at Ellie, that's also our point. What is the content your data actually is made of? So how do you kind of get, how do you understand what it is? How do you get that meaning across to the other people who might not understand what it is about? And with that in mind, today's agenda looks something like this. We'll first talk about data mesh overall. Now, this is not going to be a data mesh basics kind of an event. So I will cover some core kind of topics here, how it works on the high level and how that relates to this issue of cross-domain communication and then to data modeling. But of course, if you're interested in more details of a data mesh and so on, I do encourage you to read Dehghani's book. It's actually really well written. Not all of these are. This one is. I got mine not many days ago, so I'm maybe halfway through. Also, the original blog posts in which Dehghani explains these concepts are actually pretty well written. So all power to her. This is whatever you think about it as is it, you know, something that can be implemented at the scale? Is it realistic? I do think it is, but at least there are topics here that we kind of have to take into account, something that we cannot miss. We simply cannot afford to miss these things. So we'll cover the kind of basics there and the communication aspect, the socio aspect of the socio-technical framework here. We'll go more deeply into data modeling. So what does data modeling, the profession and the competency that has been around for decades and which some people kind of were already burying it 6 feet deep when the big data came and so on. Now, luckily things have changed again. We will cover this in the context of data mesh, so why this methodology is important in this context. And then eventually we'll end up with Ellie, the tool. What do you do with that? And why does that kind of mesh, well, pun intended, with this whole data mesh thing here? So that is the agenda. And then, of course, you know, questions are very much welcome. I will catch whatever I can. Patrick will help with that. And hopefully at the end, we can also leave some time for overall discussion if there's interest in that. But let's get going. Communication and data mesh. Now, few words about the mesh itself, just to get us all on the same level. I'm sure most of you have heard about it. You know, the whole data business talks about nothing else nowadays. But if someone hasn't, this is a framework of thinking invented by Zhamak Dehghani at ThoughtWorks. And the idea in data mesh is that this is a decentralized data management setup, and it's a domain-oriented setup. As Patrick said, it kind of shifts left towards the actual business operations and sets up data management there. The point is that we are kind of organizing everything in our data around the actual business domain. So what does your business do? And we attempt to overcome many of the problems of various centralized data management frameworks and methodologies by kind of dividing the responsibilities down to where people actually understand what the data is about. But it also kind of has to do with the idea that you should build your data teams not in the kind of old-fashioned way of, you know, having the operational systems team and data lake team and data warehouse team and analytics team, but to build them across so that they cover the domain. So analytical and operational data are basically handled by the same organization. And this domain-oriented and domain-centered team, they understand the context of that data best. They understand the interrelations within things. They understand how the data should behave, how it behaves, what it looks like, how it is most optimally handled. And they are also able to track the possible problems or issues or whatever into the very source of that thing. So then when this domain-oriented team, let's say they are the invoicing team, they manage all the invoicing data, no matter where it is. The invoicing data is born and this domain-oriented team manages it. And then they need to supply the data to the rest of the organization. At this point where we're kind of crossing the boundary of the domain, and we will be talking about domain boundaries here in a moment more, because this is the most important thing for us. When we're crossing the domain boundaries, the data is bundled at the boundary into what is called data products. And there's lots of discussion online about, you know, what is a data product, and there's data as a product and data product and whatnot. But you can think of a data product as something that basically provides data, some sort of data from that domain to other domains and use cases. And it is crucial that these data products are kind of understandable and well defined and something that are usable in many contexts. Now, this tends to mean that people get bogged down in technological issues here. How do I make these domain data products usable? And people talk about API frameworks or whatnot, and I will touch that topic briefly, not in the way many people perhaps would expect, but I will touch it in any case. And the mesh really is the network of these domains and the data products that link these domains. And the mesh is basically supported by kind of centralized capabilities which ensure that all these products are built in the same way and they are utilizing the same standards or whatnot, but it leaves the ownership and responsibility and the actual development of these products and the entire domain basically in a decentralized fashion down to the actual business experts and the business domain oriented teams. So that is the core of data mesh idea in a nutshell. I'm of course, skipping over a lot of things. I mean, this is not a thin book, and this is a one slider, but nevertheless, this should give you an idea of what we are talking about when we're talking about data mesh. So compare that to the traditional approach of a centralized enterprise data warehouse where you pull everything there and you have one team figuring that out and then you share the data from there to everything. This is kind of breaking that down. Now, to make this perhaps slightly more understandable, we need to focus on the domains. This is a screenshot of a blog by Piethein Strenghold, which I have to say this is an excellent blog post, and there's the link there. I encourage everyone to read this because this made many kind of wheels turn in my head and in many heads over at Ellie about how do you define and figure out these domains. And I'm just using this picture here as an example of what these domains could be. Now, the domains are basically your business capabilities. And of course, if you have a large organization well-versed in enterprise architecture, your business architecture should define basically what these are. But not many are doing that. So let's use this as an example. We have a fictional airline here. And we have all the different capabilities that the airline has to have in order to, run the airline. So you have customer management, pilot management, fuel optimization, cost management, and so on and so forth. So all of these domains basically are doing their own thing. And within a domain, online ticket management, you have your experts who are actually, the business people who are actually handling those online ticket sales. You have your systems, your kind of very domain specific systems that are handling this particular domain, perhaps some additional domain, but they are kind of highly focused on specific topics. And you have your system experts who understand what data exists in them. Every single domain here has its own people, its own domains. They have their own language. And the systems and people here need to cooperate across domains when you start figuring out analytical stuff. Like, for example, if you have you want to optimize routes somewhere, you have to figure out the pilots that you need to use. You have to figure out fuel optimization and so on. So these kinds of tasks that require data from multiple domains are very common when you start actually utilizing data. So now we get into the keyword here, which is cross-domain communication. We can consider this kind of a simplified picture of an organization where we have basically a business domain here. It could be the online ticket sales for the airline company or whatever. And the thing is that what we have to understand is that these domains can be internally highly optimized. So of course, the business couldn't run if you didn't have all the systems and people and processes in place and all the data going exactly where it needs to go so that you can sell these tickets. But this is often something that is handled, kind of in isolation even. The problem here is that when we start utilizing data, when we start building this mesh, even if you didn't build any kind of a mesh, You need to be crossing these business domain boundaries to figure out how to utilize data from different places at the same time. So merging data, sharing data. And this interface between domains becomes the kind of crucial point here. This is crucial, of course, in a technological way, which is something that many people focus on. So, how to enable interoperability, which is a crucial keyword in Dehghani's book, how to enable interoperability between these domains via specific solutions like, APIs or whatever. And lots of focus is being put on that. But what we're saying at Ellie, and which seems to resonate quite well with many people, is that this interface, this data sharing, requires not only a technological solution, but also a common language and understanding of what the data actually is. Because not only do these domains have separate systems and technological solutions and everything, they also have separate concepts. They have different languages. They don't necessarily understand words the same way in different domains. So if you have a customer, for example, that could mean 10 different things. And we encountered that a lot. Product is another thing. Product could mean something completely different in your factory operation than it means in your web shop. And these are problematic because the interoperability of these data products is key for this actual mesh to interlinked and work. So now we're getting to the issue here, which is kind of something that has bothered me and us at Ellie for a while now. A lot of us in the data business are focused on building this stuff. So the pipelines, how do we get this data moving? Well, there's an interface and we grab it from there, and then there's the modern data stack, if you'd like. You build your fancy codes and pipelines, and then it goes there, and everything is versioned and works automatically, and there's scheduling and whatnot, which is good and great and necessary. But the stuff that people actually need is the stuff flowing inside those pipelines. So there's some sort of a disconnect here between the very technology-focused data talk, especially in the context of this data mesh now, and the actual result that needs to come out of there. So how on earth do we ensure that the stuff that flows in those pipelines is actually the stuff that people need? Now we're getting to the core of the data product. So the invoicing domain has a bunch of data products from which it shares data to others. So what do we do? And the kind of idea and discussion that we tend to run into quite often looks like something like this. Now imagine I would be a highly trained data engineer, which I am not. And I can say that, okay, well, I'm a data specialist. I can focus now on the technical implementation of this thing. The events stream from my Kafka thingy there or are captured there, and the APIs are there. I don't have to worry about the data itself, because first of all, the data consumers, the people outside my domain there, they understand the data in my product. They, you just grab data and you look at it, you see that, okay, well, customer ID and address and so on. Very, very, very easy. Well, what we've seen, and what I think everyone has basically seen, but somehow maybe forgotten, is that this is not true in most cases. People do not understand kind of intuitively what data means when they look at it. They lack the context, especially they lack the context when they are looking at data coming from something completely different than what they are used to, from a different domain. So if your pilot management domain has to deal with your fuel optimization domain, they do not talk about the same things with the same words. Well, then you think that, okay, well, I'm a data specialist, so we have the actual data providers who create this data in the operational systems, who might be my sales reps or supply chain managers. So say they understand what the data is. So I'm just, taking the data from them and pushing it out in the data product. And if there are questions or anything, the data consumers can go to those guys and figure it out. And, I can wash my hands off this whole thing because I just create the APIs here. But this is also not correct. The data providers themselves are to a surprising degree, often unaware of what sort of data is generated from the actions they take. And this is because the systems that we've built are highly complicated, and the kind of event streams and whatnot are something that is not often very closely correlated to the actions that people kind of intuitively understand happening in the business process. Excellent examples are, for example, many financial systems where the amount of various kind of technical financial documents created by an action that I would consider a single transaction is staggering. And it takes a certain kind of mind to be able to understand that your action here leads to 5 different documents being created. It's not intuitive, and it's not something that is easy to communicate to anyone else, even though you would understand that yourself. Well, the third fallback here is then that, well, I'm a technical specialist. It's not really my problem. If they don't understand each other, then, who cares? Someone else has to deal with it. Maybe, I don't know, data governance people or someone. But this is kind of also not right. The problem here is that we all have heard those statistics that 70% of data initiatives go wrong and they don't produce anything. And the problem is that we think that we can use all the latest technology, and then we just expect that to generate value. And if we data specialists, and now I'm talking in a more general sense, all of us here, if we fail to produce value, it's not the problem for us to think about, because we use the modern data stack. But this is a dangerous fallacy. And what we kind of propose here, how to approach this mesh in a different way, looks something like this. And this is a complicated picture, so let me grab my laser pointer again. How we see that the kind of data mesh works is that, first of all, we start with the actual business domains. So you have your business architecture, you have your capabilities, whatever, and you know that, okay, well, I am now building this kind of mesh node, so this little piece of the mesh from this specific business domain, which contains processes and whatever. And then I understand that my data architecture, containing all kinds of systems and pipelines and whatnot, there's a specific part of that corresponds to this particular business domain. But this is kind of not enough. We need to also understand the language and the content of that data domain about that business domain. And we're saying that you should have the language written down. You should have a business glossary. You should have understanding of the core terms. Dehghani in this book actually talks about what she calls polysemes, which are terms that are kind of used within a domain, but also between domains, like customer, product, and so on. They appear in many different domains, and we have to ensure that we are talking about these polysemes in a way that everyone understands them in the same way. So having the language and the core terminology in a kind of structuralized fashion described with a data model of that domain basically gives us the ability to understand that this business domain gives a capability which looks like this. We have this sort of information which is implemented in this data domain, from which we produce data, perhaps with these sorts of data products, which act as our interfaces into other domains. So this kind of triangle of things, the business domain, the data domain in the technical sense, and the domain model describing perhaps overall, what the domain looks like, but especially of the data products, what they contain, what is the structure here, how is the customer entity linked to invoice, and how is the invoice linked to product, what is the product category, and so on, with the definitions of these things. This is the crucial thing that is often missing from this kind of technology-focused mesh ideas.
Juha, this is Markus. There's a question about ontologies. So could you explain the business glossary and its relation to ontologies?
Yep. Good question. Thank you. Ontology. Personally, I always try to avoid using the word ontology because it is kind of laden with academical discussion about, how to describe things. But basically what I mean with business glossary is just a simplified way of talking about ontologies. So what do words mean? What exists in the world? That could be a formal ontology if you're into that. I personally kind of prefer us just explaining some keywords and then, rolling with it. But absolutely, ontology tells us what exists and what words mean and how they are related, and that is a perfect business glossary. You could also bring up the word taxonomy, which especially comes up in data vault discussions, about how things are kind of in hierarchical classification, categorization, which is also kind of part of this whole thing. So ontologies, taxonomies, glossaries, all of this just means that we have to understand what the words mean. And the model tells us how they are linked, and it's graphical, it's easy to follow. So yes, what words mean, how you describe, what stuff do you know about the business? That is the domain model. It's a transparent way of figuring out the context of the data. This is how things are linked in this domain. This is how things are structured in these data products. And we're not talking about the technical database level models of tables and so on. We're talking about words and meanings. And I'll get back to that in a moment. But if you consider this as a node of the mesh covering one domain or two, depends how you want to build that. What the mesh looks like is something like this. So you have your nodes here, all with their business capabilities, their data domains, and the models describing what the domain and its data products are about. And then these data products are shared between domains. And this is, the basic mesh thing, how data is shared. It's shared via these products. And maybe you come up with a new domain or new use case or whatever, and you are able to utilize data from data products that exist at the boundary of various domains. But as long as you kind of have this overall understanding of what the data is about, then it is far easier to combine that data. And these models and that glossary has to be available for everyone to make this possible. So we get to the second big point here. So why data modeling is so vital as a methodology for this. And to start with that, I'd like to take a step back to think about, what data modeling is and has been always to us here at Ellie. We don't see data modeling as purely just being the physical modeling of databases, even though that is part of it. The core thing here is that we are aiming to understand what information we have about the business. This is where we have started at Ellie. This is the kind of whole point for us. We want to be able to map what information we have about the business. Who cares about systems? We start at that point first. This starting point might lead to us describing a technical solution that, okay, well, this is what exists and this is what has been implemented here. But the data modeling as a methodology, as an activity, doesn't necessarily require us to think about any technology or anything. We can and we should be thinking about customers, invoices, and products and product categories and how they link together and what they mean, even though we wouldn't know anything about the underlying systems. The data models themselves and the glossary that is kind of linked to them, they clarify the terminology that we use in a specific scope area so that we can share the meaning behind words. And by sharing the meaning behind words, we enable cross-domain communication. A quote here that I've been using for years because I just love this. This is perfect, basically, is from Alex Sharp saying, a data model is a description of a business in terms of the things it needs to know about. So we're modeling the business. We're not modeling a database somewhere, at first at least.
There was a question from Antti about data modeling and the details involved. What remains within the bounded context and what becomes interdomain? Are you going to focus on that later on, or can you ask?
Excellent point. Yeah, I wasn't going to focus on that, but I can say a couple of words. This is an interesting question because certainly there are kind of domain-specific things that don't even exist outside a specific domain. These could even be terms. So you have words that are not being used outside a domain. You have words that are being used between domains and so on. You have models that are kind of internal to a domain, but you also have models that cover perhaps multiple domains. And there are models on different levels here. And I think management of these models, management of, what model belongs to which domain and so on, this is actually something quite important. And, one of the reasons why, for example, in Ellie, you can group these models and figure it out from there. But this is, I don't think we have kind of thought about that yet enough. But I do think that there's quite an interesting area here to be kind of discovered. How do we figure out what parts of models are specific to one domain and what is kind of overlapping? It's an interesting topic. And Dehghani, by the way, in this book, talks about letting the domains do the modeling. So her view is that the domains themselves should be modeling their own things. But then we cross into this cross-domain territory, which at least I may be halfway through, at least we haven't covered yet in this book. And let's see. But this is an interesting question because the polysemes, the entities that are shared, they certainly exist.
And Antti comes up with another question. So concept modeling is cross-domain by default? Question mark, and lower level data modeling is intra-domain by default, or is that too simplified?
Yes and no. Actually, the next slide might shed some light on that. So the question is, what are we actually modeling? And the idea here behind this kind of business-focused, domain-oriented modeling that we've had at Ellie for ages now is that the target of the model is always a slice of real world. So we pick this slice of reality, a scope from the real world, which is our model scope, from which we create the model. We model what exists in the reality. And this is on the conceptual level here. And that might be defined by, a project. The project covers this area of the world, so we have to model that. It might be an organizational department, whatever, that covers a specific area of the real world, so we model that. Or it could be even something that, this particular system covers this area, but we're lacking documentation, so we need to cover that area with the model. But we are always modeling the slice of reality, no matter what are the boundaries of the scope. Now, if the boundaries of the scope are purely within a specific domain, then of course, that is internal to that domain, but not all scopes match always with the boundaries of domains.
Okay.
So we're modeling reality, and there are different levels to models. Of course, there should be no new information here to anyone, but just as recap, basically, the business glossary is kind of purely business focused. We're not thinking about systems. The conceptual data model, which is what I've been talking about here until so far at least, is the description of what information should exist about these things, how they are linked. And the scope of that model could be anything. The logical data model moves a little bit further into the IT direction, telling us how we want to organize a specific scope, specific set of data in order to serve a specific use case. So that could already be kind of a mini scope from the slice of reality that, okay, we want to take that part of it and model it in a way that is optimal for this particular use case. So it's kind of an implementation specific detail, even though it doesn't necessarily still consider the technological solution, which is covered with the physical data model. So here you have decided that I will be using SQL databases or whatever, and you create your physical database based on the scope defined by the logical data model, which is based on the structures defined by the conceptual data model. And here you go into the full IT end and do the technological work. The idea here, of course, is that by working through these model steps from left to right, we gain a better awareness of what the data is that exists within that domain. We cooperate between IT and business far better, and the the whole business is far more efficient and faster to get answers from the data.
Some companies talk about domain data model.
Yep.
Where would that be? Is that somewhere between conceptual and logical, or is that?
I kind of think I kind of like to think that a domain data model is just a conceptual data model where its scope is just the domain. The level of detail between various conceptual data models might change, and I do know that, for example, some people like to define a contextual data models as the fourth level, even more abstract and so on. But I kind of like to think of this as basically having to do with how you choose the scope and how much detail you want to add into it.
And then Steve Hoberman often talks about the business terms model.
Yep. Yeah, which I fully understand Steve's point there, because we are talking about business terms, but I tend to default to this conceptual data model word here.
Okay.
Matter of taste, I suppose.
Good.
A word about Ellie at this stage. Ellie does basically the glossaries. We have the conceptual models, we have the logical models. I hope we have in our kind of roadmap, we will cover also the physical data models at some point, but our approach is to approach this from the left. So this is kind of the thinking that we have. And what you gain of this in the data mesh context is that your data products become understandable, because we have to really know what the consumers are actually interested in. They're not interested in database tables. No one is. They want to know, something about logistics costs. They want to know about the customers and segmentation and so on. So of course we should be defining the data products in these terms. And this is one aspect of the whole mesh that Dehghani talks about, is the discoverability of these products. So how do you discover what data we have about logistics? Well, we define it in terms that, relate to logistics, instead of, a technical API documentation or database diagram directly from SQL database. No, we need to define what the data is about. So we use conceptual data models to specify the things that the data product is about, how they interact, how they are linked. So we kind of replicate the narrative part that people are actually interested in. And this makes the data products something that are easy to approach for people from outside the domain. They can understand what is going on. This is closely interlinked with the fact that we need the glossary. So we need to understand what do we mean by a product. We need to have examples, definitions, synonyms maybe. We need to know how it links to other entities. Common language has to be in some sort of an accessible repository. Not saying that the glossary has to be predefined and be predetermined centrally and so on. No, I'm saying that we need to make it available for people so that they can understand, that when we are talking about customer, someone else might be talking about client. Okay, how does that differ from prospect? How these are linked? This is something that we only can figure out if we have access to those models, describing what the domains think the world looks like, the products are, something like that, and then how we see the differences between these different terms. Another interesting benefit that we also see outside this whole data mesh discussion is the governance aspect. So how simple it becomes to govern this data when we raise the abstraction level a little bit. Instead of figuring out, policies and rules and everything on database or even column level for individual systems, we just consider that, okay, delivery data is, we deem that this is customer transaction data. It should not be shared outside this domain or something like that. We set data owners based on this, and then we can from there kind of drive downwards and see, okay, well, in which systems and which tables do I have delivery data? So we can simplify the act of governance by raising the abstraction level with good data models and glossaries.
Hey, Juha, there's a question about master data management and reference data management, and I thought that this is a good picture.
Well, actually it is, yes. Yeah, good point. Yeah, it's a whole another topic, but just saying that in the process of defining this data product, defining these models, we can also decide that, well, you know, vehicle is a master data entity which is managed centrally in, you know, somewhere. So this allows us to see what are the master data entities that we should manage somehow centrally. Peter Stranghold, I think, has written a good article also on master data management in the mesh context, and data quality and everything. So raise the abstraction level first, figure out, you know, this goes there, that is matched with that, and then we can go on building the APIs here. Also, the same thing with data management, I mean, master data management, data quality and everything. So the act of building this thing basically comes down to the business experts, system experts, the data people, all cooperating, creating the data model so that it can be used to produce the actual data product, but so that it also kind of keeps adding into the enterprise level glossary and the collection of models there, the repository of information architecture, basically, that can be built easily by just adding these data models into it. Of course, there has to be some sort of, you know, harmonizing activity so that we don't use the same words in different contexts and so on and so forth. But this is kind of something that also happens naturally when people do this based on a centralized repository of models rather than individual documents. We have an example here. I'm not going to go deeply into details, just mentioning this, that one organization we worked with, they had this kind of an idea that they would build these data product APIs based on the information and the structures they get from conceptual data models, which are mapped to physical data sources within a data catalog. So this was kind of a thing where Ellie and a data catalog were interlinked in order to be able to provide both the technical metadata and the business understanding necessary for building in an automated fashion these data products. So very interesting case. I'm not going to be spending more time on that now. The core thing here is that the data mesh becomes easier to navigate. We achieve a faster data discovery. All the data has context. We're in a position to more easily utilize these products. The terminology and everything ensure that we have the shared understanding across these domains, and the whole improvement of this cross-domain communication has its own benefits. We are more efficient. We don't get bogged down in discussions about, you know, what does that mean? What does that mean? The data sharing in itself is a goal here. We share data, we innovate on that. So this is kind of our view on why we should consider data modeling to be essential to the whole data mesh setup. And actually, you know, many of these points here are applicable in non-data mesh situations as well. Everyone has those domains, everyone has those separate languages and so on that you have to figure out. It's just that data mesh brings that all to the table at the same time and makes it absolutely vital to get it right. In the end here, I'm going to spend just a couple of minutes saying a few words about Ellie as a tool, because, you know, of course, this is precisely something that we want to do. And the idea for us is, and has been before this whole data mesh debacle and everything, that we want to make data modeling something that basically enables this communication. And this is what we've been talking about all the time. Data modeling doesn't have to be highly sophisticated and very precise activity. We need to have a fast and easy way to quickly grab what this is about. So what do you mean by customer? How is it linked? What data do we have about this? Ellie as a tool is completely cloud-based, very easy to use, very fast to produce this. And we've seen that it's also very easy to communicate with your business experts about these things when using Ellie. It's not too complicated. They don't run away screaming from it. We do models. You have your conceptual models, which are linked with the glossary. So the glossary and the conceptual models are basically one and the same. You have logical models, which you can link up with these conceptual entities so that you understand what the logical model is about. And the idea is that the collaboration is easy, multi-user functionalities, etc. And you can integrate stuff into Ellie, so you can grab those models out. And as we saw in that example a couple of slides ago, basically already utilize that in an automated fashion to create something automatically. Conceptual models, logical models, basically meant to define what exists. description of a business in terms of things it needs to know about. Logical models, kind of an implementation design, which can be linked to this conceptual understanding, implementation design of a specific data product, perhaps, or a specific data mart or report or whatever. And all is kind of built on top of this idea that the glossary unifies everything. Every conceptual entity you create is unique. There's just one customer entity. If you have something else that is called a prospect, then you define another entity, and these are reused across all the entities. This gives you a kind of a holistic view of what is linked with what, even though the individual models might only cover small scopes of the reality as it was. So this basically leads to the kind of final slide here of where we are going with this whole thing. And I think this matches quite well with the idea of data mesh and this kind of interconnected network of everything. We aim to build something that kind of gives you the ability to zoom in and out and see how things are linked on a grand scale. We're not just talking about individual model diagrams here. We're talking about linking all of these model diagrams on all the different levels, including the physical, which eventually will be there, in such a way that can be easily accessed, easily maintained, in which you can link more and more metadata, which you can integrate with different sorts of things, giving you the kind of enterprise view that we call Google Maps of data. And when we start building that sort of a thing, we kind of also think that there are more things that we can do to help, which relate to the fact that modeling is it's work. And when we start getting these linkages between everything, we can also start to be intelligent with it. We can start figuring out that maybe you should be linking this and that and suggesting things for you, giving you perhaps some analysis of how things maybe are, some corner of your architecture might look a bit weird compared to something else, and so on and so forth. This kind of help that we could keep doing this whole thing. But at the center of it all, we have the models, because the models describe the reality, they describe what actually exists, and they give you the glossary, they give you the terminology that you need in order to understand what is going on across all different domains here. And we really see this working quite well in this kind of data mesh thinking. It is part of the centralized architecture as a tool, but something that can be very easily decentralized in terms of actual usage, where domains can model their own things while still building up that centralized glossary.
Juha, can you open up the relationship between Ellie and data catalogs, especially maybe Collibra, because there's a question about the differences between Ellie and data catalogs.
Good point. Yeah, yes. Thank you. I will
make a clear distinction between those. What's
absolutely
the actual? Yes.
I will use this example as a background for this. Integrations for us are important, and we aim to have also physical metadata in Ellie, but we are not kind of looking into creating another data catalog. Data catalogs are experts at getting the technical metadata automatically from a million different source systems. And data catalog projects that we've seen, they involve hundreds and hundreds of integrations and huge amounts of technical metadata all lumped into this fancy catalog tool that you have, and they are great at it. The problem with the data catalog implementation, when it's done that way, bottom up kind of way, usually is that you don't understand the context of that data. And if you don't understand the context of your data, then your ability to understand the data from other domains, from systems that you're not familiar with, goes very fast, very down. So the idea is that Ellie gives you the ability to figure out how things are related, what is the context of invoice, what is the context of the product, how these are linked, and then basically with the catalog integrations that we have and that we are working on, to be able to map that with the technical metadata within the catalog. So how we like to look at this is that Ellie is something that you can add on top of the data catalog to bring that business information, that understanding of the terminology, understanding of the conceptual reality on top of the physical metadata that your catalog so expertly crawls from all around your databases.
I guess that's also the answer to Peter Campbell's question about your unique selling proposition compared to the Colibras and the power designers and what is it?
Indeed. And if I may add to that, the selling proposition here is that things are made we're making complex things less complicated. We're not making complex things more complicated. We're doing the other thing. And the focus is really on getting the business understanding right and then deriving everything from there. If you consider the, let's say, legacy data modeling tools, they are highly focused on delivering a database, DDL statement that you can run and you get the physical database, and everything is kind of subject to that. We're considering this, that, this is about the data content, how we figure it out. And compared to data catalogs, they don't have the modeling in there. You don't understand the relationships between things in a data catalog. You just understand that this is this data and this is where it came from, and what does it mean? But yeah, if there are any further questions, I'm happy to answer them. We can discuss topics. Just one thing I would like to highlight here. Let's even draw a circle here, fancy circle. Trial available. Our website, ellie.ai, should have a fairly large button for that. No strings attached. Maybe Markus will call you, but that's all it takes. Feel free to also catch me up on LinkedIn or our YouTube channel, where we have all sorts of previous webinar recordings and whatnot. I'm always glad to talk about these topics. Any questions from the chat or anywhere, Patrick?
I don't think so, but if anyone has final questions, it's about the time now to raise your voice and ask your questions, or your doubts, or your concerns about certain things which you don't agree with. Peter says, I can only agree that the tool landscape is very fragmented. He worked for that with many tools in many years, and he will check the YouTube videos and the websites, and he thanks you for the presentation.
This is Jean. I have a question.
Yep.
So for a while now, I have adhered. I stick to the principles exposed here during the presentation. I'm used to completely decouple business information model and, let's say, canonical logical data model, and split pieces into business capabilities or domains. That's good. Now the problem comes when you have to aggregate data from several domains. Would you have some comments on this?
Yeah. Aggregation and kind of merging of data from different domains is an interesting topic. And how we usually tend to see that is that in the end, even though you would end up merging your data even into the same table from completely different things, you still have that kind of conceptual data model behind that, which tells you that the data that I need in this particular use case is about customers and invoices and whatever, even though those things might be from different domains. So this is perhaps a case of kind of cross-domain model, really. Personally, I like to approach this in such a way that whatever the data need is to kind of combine data from different domains, I still create one model that describes my scope as a slice of reality. If it covers multiple domains, then it does. And in the end, I might end up doing all kinds of, data wrangling to get there in terms of logical and physical model. But the conceptual data model tells me how to do it. It tells me that, this is the path that I can link these things. This is actually kind of a topic I will be talking about in Knowledge Gap event in early June, about how to kind of build dimensional models out of conceptual models when you kind of have to follow these paths. But when you start with the conceptual model, which tells you how reality looks like, you cannot go wrong really with that.
Okay, thank you. There was another question about versioning. in Ellie, does that exist? Is that implemented?
Not yet, but we have been getting lots of questions about that, and it's certainly something that we will do at some point. So right now, of course, you could grab exports out of the models, and there's undo and redo and whatnot, and you can see who has changed the model and when, but going back to previous versions is not currently possible in Ellie. I'm quite certain that it will be at some point.
And that intelligent support, so a knowledge base with best practices in modeling and so on, to support people who are maybe new or not so experienced in data modeling. Is that available, or is it also in the pipeline?
Yeah, there's basically kind of two things to that. So we try to give people support as much as possible in terms of how to do good modeling already. And we have documentation, we have a special series of blog posts about kind of best practices, how to do specific things, how to model well, basically. We do trainings for all our new customers, always with a lot of focus on modeling well and doing good models. And the second aspect of this, which pertains to the roadmap thingy, is basically how to kind of build that sorts of maybe context-specific intelligence into the tool itself. And this, I think, is something that is very, very exciting and interesting. And I'm personally quite excited about it. I can't make any promises when we get there, but we do have kind of visions of how Ellie could help you while you are modeling, so that you don't have to go, into a blog post to see that, okay, well, this sort of a pattern might look good here. So there are interesting possibilities here.
Fantastic. That would